welcome once again for this Archicad for Engineers webinar series 1. The topic of this series is BIM Digitalization and Archicad for Engineers. And this series is hosted by Nanyang Technological University, Singapore, and co-presented by GRAPHISOFT, Singapore. So the speakers for this session are Teddy Wang Yongki, Research Associate, Center for Urban Solutions, School of Civil and Environmental Engineering, Nanyang Technological University, Singapore, and Vimal Kumar, myself, a BIM consultant from GRAPHISOFT, Singapore. So in this webinar series, this webinar series will be conducted for next 6 weeks on every Wednesday at 5 p.m. So the webinar is going to target the workflow of structural engineers for creating their structural BIM model using Archicad. Not just for creating the structural BIM model, but also for creating the structural analytical model using Archicad. So we will basically go through the steps and procedures, starting from setting up the project for creating the structural BIM model and all the way till the submission, creating the deliverable files, and also the coordination that is required when you're collaborating with different project stakeholders using multiple other softwares. We will also be going through the procedure to create documents, do the detailing, creating the schedules, and also calculating the buildability score and concrete usage index for submissions. Okay, so it is highly recommended for everyone to attend all the sessions in order not to miss the workflow of this entire structural BIM model creation. Okay. For today's session, Teddy will present the BIM digitalization following this, and after which I will show how to set up the structural BIM model in structural BIM project in Archicad using the information that comes from the architectural team. Okay, so I request Teddy to do the presentation on BIM digitalization. Teddy, I am making you the presenter. You can start presenting now.
Can see my screen, Vimo?
Yeah, I can see.
Okay, we are. So, okay. Good afternoon, everyone. My name is Wang Yongqi, and now I'm working for prof at Nanyang Technological University. So today, my topic is BIM, robotics, IDD, AI, and the construction digitalization. So today, I will introduce my topic based on the projects that we have finished in recent years. This project were funded by different government agencies in Singapore, such as BCA, SBB, and GTC. So as we all know, we are facing a lot of bottlenecks in our construction industry. We are relying on more manual works in current situation. For example, for the crane operators, they should rely on the site supervisors when they are hoisting a precast component from one place to the other place. And also, we are using a lot of hard markings or precast components for the aim of identifying different precast components. So these conventional methods have impeded our efficiency improvement. In other words, we need a new digital methodology. So the first project is about the smart precast logistics management. So in this project, we have developed a system to ease the process of precast production. So the system covers the 7 stages of the whole process. The first one is the precast production, and also the last one is the component installation on the site. The whole process also includes the delivery and the DO stages. In this system, the status of different precast components will be checked. The system has achieved real-time communication between different parties of the project, such as the managers, drivers, or even the workers. Okay, this is the whole workflow of this system. We can see our precast component can be checked in the whole process. When making the precast component in the factory, we will type RFID to each component. This RFID will store the information of this specific component, such as the material information and also the level information. Then the precast was delivered to the site. And also, when the truck with the precast components is arriving the site, the RFID reader fixed on the gate will read the information of this RFID. So the information in this RFID is exported from the BIM model directly. Then once the reader reads the information, this information will be uploaded to the cloud server. The later measures will be conducted based on this information. Moreover, we also achieved the smart query. The GNSS sensor has been used to track the location of each component. And this location information will be updated in our BIM model. As a result, our manager can know the location of different components only in the office. Okay, this is the RFID, and this is the RFID reader. The worker is reading the information from the RFID. Okay, and also to ease the work by the crane operators, we also installed a series of cameras. For example, we install a camera here, and we also install a camera in the cabin. Then the operators can know the exact location of each component when he is hoisting the component. In this case, the site supervisor will be free. Okay, this is the dashboard that I have previously mentioned. In this dashboard, it will present the information and status of each component. For example, what the component is precasted, delivered, or installed. The information will be updated here. So the managers can know exactly the status and also what has happened to each component. Moreover, once the status of each component is changed, the specific person will be informed by message. Okay, these are some news about this project. So the second project is about the underground project. In this project, we are going to find the pain points of the whole workflow for a real project using the VSM methodology. Once we have detected these pain points, we will try to narrow the gaps by developing different APIs based on Revit, Archicad, and Solibri. And we also have adopted different software to narrow the gaps, such as the solving. So the first solution is to generate the 2D schematic drawings from the MEP model. The second one is to build the MEP model by placing the MEP families automatically. And we also use the solving for rule checking. And another solution is the process of communication between the Navisworks and the Revit. So in this project, we have achieved good KPIs. These solutions have helped the government agencies save a lot of time and improve their efficiency. So the third project is the enhanced precast shop drawing. In this project, we have built a series of standard precast components. By using these components, we can build a building. And also, by using this model, we can generate the shop drawing automatically. The shop drawing will be used for precast production directly. This is the shop drawing that has been generated. So the fourth project is the Eurocode compliant precast design. In this project, we aim at improving the efficiency of the designers. The basic procedures are like this. First, we have a BIM model in Tagla structure or other softwares. Then we try to extract the information of each component and use these properties to design the component, such as we try to find the required bars of each component according to the Eurocode. These calculations are conducted based on the Excel template or text. Then the calculated information, that means the bars, will be built in the model. This model will be used for the production directly. By using this method, the work that should have has been done by the designers has been reduced to a large extent. Okay, the fifth project is the precast robotics work cell. I will use a video to demonstrate this. So in this project, we have developed an AGV to transfer and deliver the precast component. Okay, this is the demo. So this is the structure of our system. These are some parameters. For example, we have the loading area, workstation, and storage area. So the components will be transferred by AGV between these different areas. So this is the loading. This is the AGV. So in the first step, the system commands the AGV to move the PBU from loading area to the workstation 1. We can see here, the loading will be transferred to the new place. The worker in the workstation 1 then requests the job and is ready. The AGV will transfer the load component to the specific location. Then, in the second step, the worker in the workstation 1 completes the task and requests for inspection. So once the inspection is over, the system commands the AGV to move the PBU from workstation 1 to workstation 2. We can say it will be transferred to the new place. Then it will repeat the steps from workstation 2 to the new storage area. We can say it will be transferred to the new location. Okay, in the last project, we have combined the drone with the AI technology together. In this project, we are going to detect the defects of a facade of a building uh, using the drone and AI. So in the first step, the drone will take the photo of the facade of a building. Then these photos will be uploaded to an online platform. Then our AI will be run on these photos. As a result, the defect types and also the severity of the defect will be returned to our online system. Then this system will in charge of the presentation and also the final report. Then by using the final report, the professional engineers can ease their job to a large extent. So in this project, when compared with the conventional method where the workers have to be hanged by a rope to take the photos of a facade, it is much safer. Moreover, by using the AI technology, we can obtain more precise results. So it has achieved a good performance and improved our efficiencies. So we believe by keeping deploy different technologies and advanced technologies, our construction industry will have a better future. Thank you. So I pass this to Vimo. Later, if you have any questions, I can answer you.
Thanks, Teddy, for the presentation. Yeah. Okay. So I will go ahead after this. I will go ahead with the project setting up for structural BIM model using the information that we received from the architectural team. Okay. So Archicad for engineers. As we all know, Archicad is not just for architects; it is also for engineers, either be it the structural engineers or the MEP engineers. But for this webinar series, we are going to concentrate on the structural engineering workflow. And before going through the project setting up, we will just see a short video how Archicad can be used to create the structural analytical model within itself, and then we can transfer that information to a analytical software, analytical tool that can do the structural analysis. So this is an integrated model which has our key structural and MEP components inside. So we are concentrating on the structural components in this session. So in Archicad 24, with just by one click, we can see the structural analytical model of load-bearing components of the BIM model. In here, we can make the physical components transparent, and then we can see the nodes by switching on the nodes. You can see all the nodes are green in color. These nodes are automatically created based on the rules that we set in Archicad. But whenever a component is not connected, you can see that the node become red in color, indicating it is not connected. So all these rules for generating the model the structural analytical model, we will see in the next session. Here you can see the profile. You can see the local coordinate system. We can see the edge and end releases. inside the Archicad itself. So we have a special interoperability translator called the SAF translator, structural analysis format translator, using which we can export this structural analytical model from Archicad by using this import and export translator settings. So we can predefine this translator settings and then export the model into a local file, or we can even export it to a BIM cloud directly. So that the project stakeholders can access it from the BIM cloud. Yeah, so here is the workflow where anyone can store the information in BIM cloud. Coming back to eTabs, we can just create a project using the default settings, and then going to the tools, SAF import export option, we can import the SAF into this eTabs. So here is the very simple interface where we can choose the elements that we want to import. Currently for this demo, we can use all elements, and then choose the SAF file that was extracted from the Archicad, and then click import. So you can see here the structural analytical model is created inside the tabs using the export SAF export. So here is the physical model. We can check the geometry, the properties of those components. Currently in this version, it is not handling the load, but the future version of Archicad will be able to handle the loads also. So having done this, the structural engineers can apply the loads themselves and then run the analysis. During the process of analysis, if there is a change in the geometry of any of the component, like if you increase the size of a beam or a column, this information can readily be exported back using the same plugin in a SAF format, and we can import it back inside the Archicad model so that we get the information, the changed information, we get it seamlessly. Okay, so using this approach, it is not just easy for the structural engineers to create the model inside their structural analytical tool, but also we can link the structural components of BIM model, structural BIM model, with the calculation that is done in the analytical tool, which is very useful during the submission. We can link both the information very easily. Currently, with the detached way of working, where people create the structural model individually and the analytical model individually, the linking of these two information to the corresponding components is a bit tedious. So having seen this, we will go ahead and see some of the approaches that we can strategize to set up the project for creating the structural analytical model. Okay, so depending on the information that we received from architectural team, either be it 2D information or the 3D information, 2D information can be in the drawing format, that is the DWG format, or if the model is in 3D format, it can be either in IFC format or if it is in Archicad model itself. So we can strategize to set up the projects in different ways. So we'll go ahead and see one by one. So using the architectural information in DWG format, we can see that we can import all this drawings, architectural drawings that consists of the site drawings, floor plans, elevations, sections. If details are available, then it is good enough. So we can import all this information into a structural model inside Archicad and use these drawings as a reference and start creating our structural model. This is the very traditional approach that is followed for creating the structural model inside Archicad. And the other approach is to have the architectural model itself in 3D format. If it is from the Archicad, then it is good enough. We can simply reference the views from architectural model into the structural model and start creating our structural components based on the references that we have created from the architectural model. But in case if the model is not from Archicad, the architectural model is not from Archicad, if it is from the other authoring tools, we can export the IFC file, and we have to create our we have to create an architectural file, architectural project inside Archicad using the IFC by hot linking it. Okay, so meaning we are creating an we are creating an architectural project based on the IFC file that we received by hot linking, and some information like the north in the boundaries setback may not be available in the IFC file. So for that, we can go back to use the site drawings and then import it into the architectural file. So using this, we have an architectural model inside Archicad, which we can go back to the same previous method of referencing the views to the structural model, and then we can start creating the structural components by referencing. And the final approach is the most efficient approach, where both architectural and structural team will work in the same model. So here, architectural team, once they create the model and they come to a stage where they collaborate with the structural team, they share the model into BIM Cloud using the teamwork features. And from there, the structural team can join the project and then start using the information in the teamwork project. And both of them can do the changes seamlessly by sending and receiving using the teamwork features of BIM Cloud. So this is the most efficient approach. Okay. So I will go ahead and show the demo of all these approaches. But before that, I will show where we can download the templates of Archicad projects. So this is the website from which we can download the templates. Going here, we have architectural BIM template. We also have a guide for that. Below we have the structural BIM template, and we also have a template guide for Archicad 24. And we also have MEP guide. You can download it from this website and start using it. For users from Malaysia, you can still use this template, but you have to change the information or the settings of these template files to suit your needs. Okay, having seen that, let us go ahead and see the procedures or the approaches for each and every method. First would be the drawing using the DWG file from the architectural team. Okay, so for that, I'm just creating a new project. After downloading the structural template, I just go here, browse the template. For me, it's already in the list, so I'm just using it here. And then I'm using the structural engineering profile. And then create new. Okay, so now we have created a project with the structural template. So the first thing we have to do inside this is to adjust the story settings. So go to the map, project map here in the navigator, and then right click in any of the stories, and then go to story settings. So inside here, we need to change the stories depending on the height of the stories from the architectural model, and then click OK. So we can delete the unnecessary stories that are available on this template, and click OK. So I have already created a file with the necessary information. Go here. You can see that I've changed all the settings here, the height of each story, and I've changed the name of them depending on my architectural model. Okay, so that is the very first thing that we need to do here, and click OK. So okay, if you don't want to see the grid, the construction grid, you can just delete it. You can delete this information here. Okay, now we need to start importing the information from the DWG file into the model for referencing. So for that, I can create individual worksheets. I can go right click on the worksheets from the project map and then click new independent worksheet. So inside here, I can give the reference ID and then I can give the name of the story that I'm going to import on. This can either be a story information or the sections or elevation, can be any drawing or even the site information that contains the topography and the site setback and the boundary information. Okay, so I've already created few that is required for this demo. So here we have the site information. I'm going here and then I need to import by just dragging and dropping the DWG file into this worksheet. So I'm choosing the DWG file from here and then dropping it here inside. and I'm choosing the unit, which is 1 millimeter. You can see your site information from your DWG file here. I can move it to any location that I need. I'm just resizing the frame of this drawing so that I can better view the site boundary. So you can see here, this is the site boundary, and here this is the setback of the site, and then here are the grid information, and we also have the true node, the project node inside here. Okay, so having got this information, we can go back to the first story, and we can select this site information and show as reference. You can see here it is coming as reference. To better view the reference, I change the color here. I adjust the opacity of it in order to not disturb with the view model. Okay, so having done that, I can go ahead and trace this information and create my own grids here. So here I can use the grid settings, grid system here, and I can enter the information here. Okay, so I need to enter the information based on this, or I can even go ahead and create my grids one by one using the option under the document toolbar. Go to the grid element tool. I can start modeling. Okay, so you can keep modeling everything. Okay, so after drawing everything, I just want it only on one side, so I can change. Imagine that I've drawn everything, and I can just go and group everything together as one, and I can also draw the setback and the boundary information. And now if I want to set the true north, go to the options, project preferences, set project north. Okay, so I set this and set the direction as 70 degree. Okay, so if you want to have component there to indicate the project north, you can just go to the objects and search for north symbol. Okay, so inside here I can choose the style which I want to have. Maybe I'll choose style number 4. I can choose follow project north, and then have this reflected on all stories. Okay, and done that, I will go ahead and place it here. Okay, before that I need to choose the layer. Go ahead and then choose the layer. Click OK and click show layer. Okay, so my grid information in the boundary and north information can be brought inside the structural model using this way from the architectural drawing. So I have to go here and then update the. Okay, so I will just show visible out. Okay, so after this I need to bring the stories. So I just go here, which I have created a new worksheet already, and then I will bring in the first story from there. So I'm just dragging and dropping the DWG file and choosing the unit. can see the architectural drawing here. From here, you can start tracing the components and then start drawing your components. So if you see here, this is your structural wall using which we can trace and draw the structural wall from here. Okay, so going back to first story, we can show this as trace reference and then move it to the proper location. And we can start referencing this wall. So yeah, using this way, I can create my structural BIM components, which I'll be showing in the next session. For now, we are just going to set up the project, which we have already done using the DWG files. Now we will go ahead and see how to set up the project using the Archicad model, which has the architectural model inside. Archicad project, which has the architectural model inside. So I have this empty project where I have changed the story settings as I did earlier in the previous file. And then I can go to the references here, the layout book here, and then create my own reference. Okay. So here I will create a new layout. I will name it Archi first story. Okay. So this is empty. So now I'm going to bring the information from the Archi model. So I'll show the Archi model here. So this is the Archi model which we are going to use for demo today. So here you can see in the views, we can see the first story, second story, and all. And we also have the site information here, which has the topography or the setback, the boundary, and the grid information. So we are going to link this information with the new file. Okay. So having created that, I just go here to my navigator and then choose the Archi model. I can see all the views and the references there, the layouts. So from here, I'm going to choose the first story and then place it inside my Archi structural model. Okay, so I can adjust the size of the view here. So in this way, I can bring all the views like first story, second story. I can bring the sections, elevations. I can bring the site information and all. So after bringing in everything, I go back to the project and then go back to my first story. And I can trace this drawing as a reference. Yeah. So I have some predefined settings which I can delete. So I can change the reference color as I did earlier and also adjust the opacity of it. If I want to move it or rotate it, I can do it using the options here. So after bringing in here, we can trace the components inside this and then we can start modeling our structural components. We can also bring as I told earlier, we can bring the sections, elevations, and the site information also using this method. Okay. Okay, so the other method is by using the IFC file. So for IFC file, we need to create a new Archi model. So I'll delete this information. I'll use the same model to create my architectural model using the IFC file. Okay. Okay, just remove the trace reference. Okay, for bringing in the architectural model for hot linking, I just go to the external file, external content, place hot link. So after that, I select the module here and click new module. From the local file, if you are using BIM Cloud, you can choose the file from the BIM Cloud directly. So for now, I'm just using the local file. I'm choosing the Archi model, which is exported as an IFC file, and you can choose the translator here is the general import translator. Okay, and select. So it takes a bit of time to load. You can adjust the height of the components from your model, and you can place the hot link. Okay, so I can use embedded library or I can use the external location also. I'm just using the embedded library here. Okay, the model is getting loaded. Yeah, so the model got loaded. I can choose the story, but since I've given the story settings exactly the same as what is in architectural model, it automatically matches the right stories. So I just click OK here. Okay, so I will go ahead and create a new layer combination for this IFC file that we just imported. I'm just creating new RP reference IFC and click OK. So inside here, we can just see all the IFC model and make sure everything is shown. So if it is shown, you can just click OK. If it is not shown, just make sure you have to show it. Okay, so after this, I can choose the ARCI reference IFC. And inside here, I'll choose no overrides. So with this information, I'm able to bring the architectural IFC file inside here, and I can create the views. So here, just go ahead and choose the ARCI reference file or reference layer combination, and then redefine with current window settings. Okay, so this view will be created. Again, go back and choose the layer combination, and then redefine with current view settings. So having set up the views here, we can use the similar approach that we used earlier to just reference the model, reference this model into the structural model, and use this views into the layout here. And then using the layout, we can trace reference them and start creating our structural components there. Okay, so these are the three different approaches. We first saw the DWG, and the other one is by referencing the architectural model, which is inside the Archicad file. And we are creating an architectural model inside Archicad file using IFC file that we exported from the other metering tools. And then we are referencing this to the structural model for creating the structural components. And the final one is directly using the structural, the architectural model by both the teams, by architectural and the structural teams. If you see here, by changing the partial structural display here to core of load-bearing elements only, we can just go ahead and see the structural components. So all these components are load-bearing components, and we can easily see isolate all this information. Okay, so after this, the structural team, if they want to collaborate directly with this architectural team and the structural team together, we just use the teamwork facility here. Go to the project and share. So we can share this model to the BIM cloud, and then the structural team can use the same model and then work collaboratively with the architectural team, where they're not creating the architectural and structural model individually, but they are working in the same model, having all the information together as an integrated model. Okay, so these are the four approaches which we can use to set up the project for creating the structural BIM model. Okay. So going back to the presentation. So that's all for today. So we will be going through the other processes of creating the documentation, scheduling, and everything in the future sessions. So if you want to follow us and get instant information about the sessions that the workshop or the webinars that we do, please follow us on all the social media. You can scan all the QR code here and just go ahead and follow us. We also have a YouTube page where we upload all the webinars. So the previous webinars that we have conducted will be available there. You can see all those webinars and get benefited from there. Okay. So we also conduct trainings for basic, advanced modeling, and the advanced documentation. And apart from this, we also have multiple campaigns and discounts going around. So please reach out to us for more information on all those. Say for example, in Singapore, we have PSG funding, which has like close to 80% discount on the software packages. So here is the Learn portal, GS Learn portal, from where you can register for all these trainings. And we also have the other self-paced trainings, the video recordings of the self-paced trainings available on the GS Learn portal, from which you can learn and get benefited. So we are opening it now for the Q&A. DK is asking if the slides will be shared. We'll be sharing the video in our YouTube page. You can watch the recording from there.
We will share in the YouTube channel, right? So yeah. Okay. Any questions so far? Sorry, we understand some of them couldn't able to join the session because of some link corruption or whatever. We will send the recording to everyone, whoever registered. So in case one of your colleagues couldn't able to join, don't worry, we will send a link for them to watch the recording. Yeah, sorry for that.